All right, so we're given this velocity t squared plus 3 in meters per second. Estimate the distance. So in other words, I'm going to find the area underneath that rate. Traveled between t equals 0 and t equals 5 with an overestimate with data every 1 second. So you can either draw this or you can do a table, whatever you find is easier. Let's do a table. So it says overestimate every 1 second, so meaning 0, 1, 2, 3, 4, 5. Oops, 5. And these values, so this is t, so these values are going to be v of t. So in other words, this first one will be 0 squared plus 3, which is 3. Next one will be 1 squared plus 3, which will be 4. Next will be 2 squared, 4 plus 3, 7. 3 squared, 9 plus 3, 12. 4 squared, 16 plus 3, 19. And then finally 5 squared, 25 plus 3, 28. All right. Now, as I've mentioned before, if you don't graph or kind of remember something, so I know what the graph of t squared starting at 0 plus 3 looks like, right? It starts right here, and it's a parabola. So I know that this is a graph that's increasing. So if I'm looking for an overestimate, then I need to start one value over to the right so I'm above the function. So by the table, that means I'm going to take these values. And you kind of know that with common sense because you're going to pick the higher values, right? And so I take the width, which is just 1, but we'll just put it to be complete. And I multiply it times all the heights, which is our velocity summed. So 4 plus 7 plus 12 plus 19 plus 28. So I'm going to cheat and put all that in my calculator. Plus 12 plus 19 plus 28. And multiply it by 1, of course, and I get 70, which if the velocity is in meters per second, then the distance is just simply in meters.